Okay guys, this is segment 3 of our Unit 6 video segments on naming and nomenclature. We have already gone through this slide right here, dealing with the different practice of your simple binary ionic compounds. And what we want to do today is take a look at what happens when our ionic compounds get more complex. So we're going to start with a compound like this. If we take a look at this, we have Al2, CO3, and 3 outside of it. It looks much more complex at first glance, and you might say, how do I deal with all this stuff over here? What do I call that? How does it work? And what we have to recall is that the CO3 actually comes from something we were doing in our past unit. If you recall, we had CO3 with a negative 2 charge as one of our compounds or one of our molecules that we were drawing and working with in our last unit. So at that point we just said that these molecules form molecular bonds and they have to have a charge to them to make them work. At that point we didn't really talk about where does the charge come from and what does that charge do to this molecule. In reality, what happens is, because this molecule is charged, we have a charged molecule, that molecule would then bond to a metal and form an ionic compound. So what we have is we still have a positive and a negative to our normal molecule. We still have our positive side and our negative side, but now our negative is just a bigger ion. It's not a single ion, it's now what we call a polyatomic ion, which is a group of atoms put together to make up the ion. Okay? So the goal today is to get to working with polyatomic ions and how they play a role in this naming system, because a lot of the chemicals we work with have these polyatomic ions in them. So to do that, first of all, let's kind of go through some of the definition stuff. Poly means many. Atomic means atom, so polyatomic ion means you're getting an ion from many atoms put together. So this grouping, the CO3, this whole group acts as one item. And that whole group has a charge of -2 to it. So when you're doing naming and working with these, you treat this as a single thing, as a package deal. So this whole package works as one thing in our system. Okay? Now, when it comes to naming them, we have to be able to distinguish the difference between carbon by itself and carbon bonded to oxygen or these polyatomic ions. So when we work with polyatomic ions, if you had, let's say, just nitrogen, we would call that nitride. But if you have NO3 that's in a polyatomic ion with the 1- charge, we call that nitrate. So the change here is our ending goes to ATE. If you had NO2 with a 1- charge, we have nitrite. So nitrate and nitrite are similar, but they're different by 1 oxygen. Okay? And that pattern repeats itself with all the different polyatomic ions. So your simple anions, we end in "ide". Your standard polyatomic ions end in "ate". And then a polyatomic ion that has 1 oxygen reduced from it ends in "ite". Okay? So we get these different endings on those. Now, we have some exceptions to that. 3 exceptions to polyatomic ions that you will come across very commonly. Hydroxide is a polyatomic ion OH. It's different than the ones that we're going to see normally, and we don't end it with an 8 ending. We call that hydroxide. So it's one you're going to have to memorize. Ammonium is also named a little differently. And this one is on purpose because ammonium, if you look, it's our only positive polyatomic ion. So this is the only case where we're going to have a polyatomic ion that acts as a cation or is written first in a chemical equation. Cyanide also doesn't end in 8. And it has the form of Cn. So if you notice, all three of these don't have a lot of oxygen in them. So they're a little bit different types of polyatomic ions, but they are three that you are responsible for recognizing as we go through our different polyatomic ions. Okay? Now, when it comes to polyatomic ions and naming them, we have to put 8 of them to memory. Okay? There really is no other way of doing it besides just purely memorizing these. So, if we go to that list, if we go to your periodic tables, on the back of your periodic tables, on the very bottom, you're going to see a small box that says common polyatomic ions. Okay, and if you look, there are 8 of them there: nitrate, NO3 1 minus, chlorate, ClO3 1 minus, acetate, hydroxide, carbonate, sulfate, phosphate, ammonium. These 8 must be put to memory. Okay. Once you know these 8 and have them memorized, you can build from them, and you can actually determine a lot more polyatomic ions from that. So if we take a look at how we name these polyatomic ions, we always start with this root ending of 8. So let's go back to, or let's say for example, chlorate. ClO3 has a 1 minus charge. We call this chlorate. Okay? You've memorized this one, or this is one that you'll have to have memorized. Now, once you know chlorate is ClO3 1 minus, you can figure out a lot other ones based off of this root. So if you have ClO3 1 minus is chlorate, ClO2 1 minus, so if we reduce the oxygen by 1, we change the name slightly to chlorite instead. So your ites are always minus 1 oxygen. Okay guys, that ends this segment on polyatomic ions.